Hey guys, if you missed live class today, I'll go through this with you right now. And just know that tomorrow is our final quiz. So today is the big practice day. We're talking about world landforms today. Your exit ticket yesterday, Friday, was about this question. And so I'm going to ask you again, and we're going to talk about it further ado now. Which catastrophic event do you think we should be most worried about here in CTAC? Is it earthquakes, volcanic eruptions, meteor impacts, landslides, or tsunamis? Use what you've learned. Maybe you want to use this map that might help you. There is more than one right answer, so I want to know what you think. Go ahead and write this in. Little practice here. Ingle Lake. How was it created? Was it created by volcanoes? No. Was it created by a river? No. It was created by erosion from a glacier way back in the day. We talked about this last week. I want to make sure you remembered. Is it true or false that the Pacific Northwest volcanoes, they're all extinct and they will never erupt again? Hope you know this is false. So we haven't really talked about the different classifications of volcanoes, but extinct means they will never erupt again, and ours are not extinct. Mount St. Helens erupted just before I was born, which seems like a long time ago for you guys, but it wasn't that long ago, and could erupt at any time again, and so could Mount Rainier, which is the biggest one and the scariest one. So no, they are not extinct. What do you guys think? Deeper canyons are they older? Are they younger? Were they made by something other, a river, something else? Because you can see in this picture here that canyons are made from erosion of rivers over thousands or millions of years. A deeper canyon is probably older. It also might have softer rock or something, but if you have two canyons in the same place, deeper canyons have been eroding for a longer time, so they're probably deep. They're probably older and deeper. So our final assessment is tomorrow. Let's talk about the science of the day and learning target, and I'll go over your work with you today. Deshauna Taylor is our scientist of the day. She's a little bit older than I am now, but she is a teacher. She's a geologist. She studies taphony, which is how living things become fossils, which is cool. She teaches at a college, the University of Miami, which is about the other side of the country from us. And she blogs and talks about Black geoscientists. So her blog is here, blackgeoscientist.com, and her big thing is trying to get more Black and people of color into the geosciences. She came up in a field that was mostly white men, and she had to deal with all the things that come with that. And so she wants to get more people in, diversify the field a little bit more. So, and she writes about it, she talks about it. So check out her blog if you want to learn more. She's pretty fascinating. So I will apply my learning about geoscience processes to explain the formation of landforms from around the world. If you remember on Friday, we tried to explain local landforms in Washington State. Today, we're going to take those same skills and we're going to spread them out around the world. You might recognize some things from the homeschool connection we did when we looked at landforms from around the world, because all we're trying to do is explain how our different geosciences processes have changed Earth's surface, if you remember. So remember that these processes might take millions or hundreds of millions or billions of years. They might take not as long, hundreds, thousands, millions. Depends on which landform you're talking about. Like a Grand Canyon might be millions, but a lesser canyon might be only thousands. That would be deposition, erosion, weathering. And then some things happen really quickly. Earthquakes, volcanic eruptions, meteor impacts, landslides. These things can change the Earth in a small location, but really, really quickly. So we talked about this in the very first day of this unit. These are fossils of ancient sea creatures. And we learned that these were actually found up in the tallest mountain range in the world, up in the Himalaya Mountains, really close to Mount Everest in Asia. And so today we're going to try to explain in our breakout rooms why are there so many marine fossils found high up in the Himalaya. We're going to talk about how they were formed. We're going to talk about how did they get up into the tallest mountains in the world, and why are we so easy to find today? Those are the kind of the 3 parts of our explanation. So what we did is work on this. There's a video to help you. This is a GIF. We actually watched this video, but this is a GIF to help you here. Here's India. You can see how the Himalaya are being formed as India plate crashes into the Asian plate. And then this video will tell us a little bit more about marine fossils. It helps us answer both number 2 and number 3. Please try to use the word erosion in your answer to number 3. And then, nope. Okay, so then I put 7 more slides for independent work today. Your job is to choose 3 to answer. And then you're actually going to put 1 or 2 of these into your portfolio tomorrow on the last day after you take your final assessment. So we're trying our very, very best to give nice, complete answers here. Please remember to use vocabulary from the unit. You're going to say things like erosion, weathering. You're talking about different kinds of volcanoes. Maybe you're going to talk about hot spots. You might talk about convergent or divergent plate boundaries. You're going to use all of these words to help you describe these landforms. And apparently I put this in again. So these are some of the words I'm talking about, okay? So 7 slides. I'm going to read them quickly through you. Your job is to just choose the 3 that you think is maybe the easiest, the most challenging, that you are most interested in, up to you. On each slide, I try to put some pictures to help you. I might have put a link or 2 as well to help you answer these questions. So this number 1 is, why is Japan full of volcanoes and hot springs? Look at these monkeys. These monkeys actually live up in the mountains in Japan. And in the winter, they come, because it's so cold and snowy, they come and hang out in the hot springs. And as a tourist, you can go and take pictures of them. I have been to Japan, but I did not go in the winter, and I did not get to go see these guys. In East Africa, if you look at this map, East Africa, so this is like Ethiopia here, here's Kenya, Tanzania down here, Somalia's kind of over here. The question is, why are there volcanoes? And there's a big line of lakes in East Africa. What will Africa look like in another 50 million years? Use these different maps and this video to help you. Again, you don't have to answer any one of them. You're using 3 out of 7. Describe how Halong Bay was formed. Use this description down here to help you. And then if you came back in 10,000 years to visit Halong Bay, how would it look different? How did the Andes Mountains form? The Andes Mountains are this, The Andes Mountains are this long, get myself out of the way, this long range of mountains all up and down the South American west coast. How do they form? And why are there so many volcanoes in them? Can you describe how those volcanoes formed? Here's the Nile River in Egypt. This is the delta, the Nile River Delta. How did it form, and how do you think it will change over the next 1,000 years? These couple of GIFs will help you with that. Here's Iceland. Describe how 2 different processes have helped to form the giant volcanic island of Iceland. These 2 kind of images might help you with one. The video will help you with another. If you were trying to figure out where Iceland is, it's right here. So we are kind of over here. Here's Europe and Africa, and Iceland is just this island right in the middle of the Atlantic Ocean in the very north. And the last one is about beaches. The sands on some beaches are white, black, brown, red, green, and look, this is a pink one in the Bahamas. Why do beaches have different colors sand? You might be using terms like weathering, erosion, sedimentation, deposition. Maybe not sedimentation, but deposition. There's a couple different articles here. This bottom one has a little audio, a little 7 minutes, I think, a little audio that reads the article to you. Give this a shot. Okay, so your job is to choose 3 of these 7 and answer them the best you can, knowing that tomorrow you're going to come back and choose the best 1 or 2 of them to put in your portfolio. That's it for today. Have a good day. See you tomorrow.